The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome. We're happy to see many from across the U.S. and internationally will be joining us today for the webinar. My name is Isaac Jones. I'm an application engineer here at SonTek. I'm very excited to introduce our distinguished guest speaker, Dr. Bret Webb. Dr. Webb is a registered professional engineer and associate professor of civil engineering at the University of South Alabama. He graduated from the University of Florida in 2001 with a Bachelor of Science in Civil Engineering. He later received a Master's of Science and a Doctor of Philosophy in Coastal and Ocean Engineering from the University of Florida. And Bret teaches undergraduate and graduate courses in water resources and coastal engineering at the University of South Alabama and performs research on coastal engineering topics ranging from shoreline protection to storm surge and waves. Bret provides consulting coastal engineering services throughout through South Coast engineers and has worked on a variety of local and regional national projects. He's also been working with the SonTek equipment and the SonTek M9 since it first came out in 2009 and has extensive experience with HydroSurveyor and the previous River Surveyor software. Next, I'd like to introduce and thank Christina Arasi, our Director of All Things Marketing here at SonTek. She's done a fantastic job getting the word out about this webinar and doing a lot behind the scenes to make sure everything runs smoothly. So, all right. So here's the basic structure for what we're going to go over in the webinar. I'll start out by giving some background information and then review the different components of the HydroSurveyor for those of you who are unfamiliar with the system or maybe familiar with the M9 and River Surveyor more. Then I'll hand it off to Bret, Dr. Webb, who will be presenting the evolution of his unique survey platform, the Jag Ski, and then talking about some of his recent work with HydroSurveyor and kind of the evolution of his work with the M9. Then I'll wrap it up and finish off by showing some mounting examples, some other mounting examples, and then Dr. Webb and I will answer any questions that are submitted during the webinar. So we'll be answering questions that are submitted via chat. So you're welcome to enter your questions at any time as they come up during the webinar. We'll hold off on answering questions until the very end. We'll answer as many questions as we can in the hour we have slotted for the webinar. If we don't get to your questions, I apologize, but we'll send a follow-up email that will have a list of the questions and then our answers to those questions also. So feel free to submit any and all questions. All right, so so what is a HydroSurveyor? For those of you who don't know or kind of have heard about it but haven't seen the HydroSurveyor, it's basically SonTek's hardware software system that's capable of mapping velocity, providing navigation information and depth sounding information for surveys, either for a standalone survey or augmenting a survey using other third-party equipment. And the schematic here kind of gives an overview. Here we have the ADCP down below the boat, and at the same time as it's profiling the water velocity, it's also tracking the boat's movement over the bottom and getting the depths at 5 different locations at a time. So here's some histories from SonTek, and HydroSurveyor is a relatively new software firmware package from SonTek, but it comes from a history. The basis for HydroSurveyor is the River Surveyor M9, and which came out in 2009. And as Bret will talk about a little bit, he started using it right away. Got one of the first M9s off the production lines. But here, this is showing a screenshot of the River Surveyor Live software. And this package was mainly designed just for computing river discharge from a moving boat application. So not so much a survey type application, but just providing a discharge number and profiling the water velocity. And here at SonTek, we also manufacture a compact, high-tech CTD, the CastAway CTD. So this is also a tool that can be used in surveying. It's used for correcting the sound speed profile with depth, which is needed when you're using acoustics to determine depth. And then, so with those two tools available to users, they, on their own, were already doing hydrographic surveys with River Surveyor Live and some with CastAway CTD also. River Surveyor Live maps velocity profile and depth with latitude and longitude, and these can be exported out of River Surveyor Live and used to make bathymetric maps or hydrographic maps. But the SonTek software was not designed specifically for surveying, so there was a lot of drawbacks with using River Surveyor Live for a hydrographic survey. And our users were pushing for a tool that was, our users like Bret were pushing for a tool to make surveying with M9 easier. So here's some of the details about what goes into, or what makes up a HydroSurveyor. So we have the M9, as I mentioned, which is a ADCP, or acoustic Doppler current profiler, and that provides velocity, bathymetry, and navigation. And then we have the M9 and GPS, which provide position of the boat. And then data collection and display via the HydroSurveyor software, and also navigation, real-time navigation of the boat for hydrographic surveys. And then lastly, we have the optional CastAway CTD, which is needed for sound speed correction if you're using acoustics to map bathymetry. And the advantage of using the CTD over another sound speed profiler is that it's fully integrated with the HydroSurveyor software. The cast can be brought in and then data corrected right in the HydroSurveyor software. And so breaking it down a little bit further, this the M9 acts as a 5-beam echosounder. And so there's 9 beams, the M9, but it has one vertical beam, which is 500 kilohertz, and then 4 300 kilohertz profiling beams and 4 1,000 kilohertz profiling beams. At any one time, the M9 is using 5 beams. It's using the vertical beam and either 4, pardon us for a minute, we're very close to the Miramar Air Base, so I have a jet flying overhead. Okay. So the system only uses 5 beams at a time, so depending on the water depth and the water velocity, it's either using the vertical beam and the 3,000 kilohertz beams or the 1,000. And the slant beams and the vertical beam cover a swath of 50 degrees when you're surveying. And the slant beams have a range down to 40 meters. So the M9, in addition to being a 5-beam echosounder, is also a fully capable ADCP. So you can profile velocity from somewhere near the surface, near the head of the instrument, down to near the bottom. And then it also provides the vessel speed over ground via the acoustic Doppler shift of the signal off of the bottom as the boat moves across along a survey. And one of the options SonTek provides for powering the HydroSurveyor and then also integrating in SonTek provided GPS is our new power and communications modules. And so they offer power to the system and then radio communication back to a computer, so you don't have to have the computer directly connected to the M9. That's not a possibility. They're fully waterproof, which is important for some platforms, as Dr. Webb will get into or will demonstrate with his presentation. They're IP67 rated, which means they can be submerged under a meter of water for a certain amount of time without leaking. And lastly, there's the optional CastAway CTD, which is fully integrated with the HydroSurveyor software and very compact. You can see in the photo in the upper right that's the real size compared to somebody's hand. And casts can be made during a survey and then brought right into the software and corrected for the acoustic information to be corrected in post-processing. Okay, so without further ado, I'm going to hand off to Bret and let him explain his exciting work to you all.
Thanks very much, Isaac. I've unmuted myself, so hopefully everyone can hear me okay now. As Isaac is turning over control to me so I can lead us through the next section of the webinar, I'd just like to preface this by saying that I've been using the SonTek equipment, and I'll kind of explain the history a little bit, but for the past 5 years. And I've been very impressed by its capabilities and robustness and also the level of service that SonTek has provided over the years. So it's been a very good system. I'm very happy with it, and very much enthusiastic about talking you through this webinar. We're going to talk about a few different aspects. If I can advance slides. There we go. Seems to be working now. Just a little overview of the next 30 minutes or so. Provide a little bit of history about myself and my experience profiling with personal watercraft. Talk a little bit about the development and the capabilities of what we call the Jag Ski. Our South Alabama mascot is the Jaguar. So somebody along the way, not me, I'm not going to take credit for, decided to call it the Jag Ski instead of the jet ski. Talk about some case studies and examples, and then actually as one of the examples I'm going to take you through a sample workflow of going through the procedure of setting up and conducting and post-processing some of the results. So you'll get to see a complete survey in 10 steps. Conclude with some tips and tricks, and then at the end of the presentation I'm sure we'll do our best to answer all of your questions. A little bit of background about myself. Isaac provided a very nice introduction, so I won't repeat any of that stuff. But while I was at the University of Florida, I had the opportunity to help another graduate student develop and build and also use two jet ski systems. What we should call them personal watercraft systems, because jet ski is a proprietary name. But one was for to keep at the University of Florida, and one was to provide the USGS. And so they had a research contract to develop these jet ski systems, and the deal was, well, we'll build one if we get to keep one. And so this jet ski system or personal watercraft system was fairly crude at the time. Believe it or not, we were actually using an old Palm Pilot as our data acquisition system through a RS-232 cable using Hyperterminal. And we did have RTK at the time and a standalone echosounder, single beam 500 kilohertz echosounder and RTK GPS. But that was actually surveying back before SA was disabled, so the accuracy was still not very good. Very poor displays, very crude interface with data logging capabilities. And honestly, a decade ago, when we were doing this work, actually closer to 15 years ago now, the personal watercraft platforms were not very robust. They were still very unstable. They were relatively small. Still very heavy though, which is odd, but they were much smaller, but very, very unstable. But things have improved quite a bit, as we'll see throughout the course of this webinar. The instrumentation of platforms are much better than they were 15 years ago. So the project started back around mid-2008, and the goal was really just to have a platform that we could easily store or use with one or two people. We don't have the resources and the personnel and the staff to maintain a vessel. So personal watercraft seemed like the next best thing. And somebody asked me, well, why don't you just put it on a small John boat? And I said, well, honestly, a personal watercraft is much cooler, so we'll go with that. But they are relatively affordable even for the larger platforms. We have a 3-seater, and one of the reasons why that is advantageous not only is the size is a bit bigger, it's more stable. It is heavier, which means that manual operation and lifting becomes problematic if you're trying to do that. But having the larger personal aircraft also means that as you add more instrumentation to it, you're not really affecting the stability and the buoyancy so much. Took quite a bit of research and planning. We looked at probably every single personal watercraft that was available on the market at the time, looking for the best combination of weight and power and fuel and storage and size and things like that so we can mount instrumentation to it. And we completed it sometime in late 2009 when we received our first M9 profiler from SonTek and did some field trials early in 2010, which was fortuitous because for those of you that don't remember what happened in my neck of the woods in 2010, we had a fairly large disaster with the Gulf oil spill occurring in April. And we actually used the Jag Ski during that to have some hydrocarbon distributions we'll talk about a little bit later. So major changes since we started building these systems back in 2000. The instruments are much better. The personal watercraft are much better. The display options are much more robust and bright, and even touchscreen interface now. And RTK GPS systems have advanced quite a bit. Our focus areas for the Jag Ski right now are currently beach surveys, so doing beach profile surveys, and velocity profiling for different research and for contract purposes. And we'll see some of those examples as we go through the webinar. We do also use it a little bit for coastal water quality surveys, and we'll talk a bit about that in the coming slides. All right, so there's a line sketch of our jet ski. I should have said that our system was the top photograph in the previous slide. We've got the four-wheel drive unit that we can use to tow along the beach, but really becomes more important for shuttling equipment and moving our RTK station up and down the beach as we need it. Our current package right now of instrumentation, it's actually all SonTek YSI gear. That was, not originally the plan. We didn't say we were going to purchase everything from SonTek YSI, but as we continued to use the Jag Ski, we found that they offered the most compatible products for what we were trying to do. So we have a YSI CastAway CTD that we use for the sound speed corrections and also for additional vertical profiling of hydrography, so we get salinity, temperature, density from that. We have what's called the YSI Portable Seakeeper, so it's a shrunken down version of a full Seakeeper system that's deployed on ferries and research vessels and cruise ships around the world, and also private yachts. And the Seakeeper system came about as a result of the oil spill. We got a grant from the National Science Foundation to work with Wide-Size office out of St. Petersburg at the time to develop a smaller Seakeeper system. And it's the larger case that's on the back of the personal watercraft, and that lines kit that's vertically oriented. It's got a cable coming out of the top. Just a large pelican case with multi-parameters on the inside and a pump and it's some standalone computer and telemetry and GPS unit. So we get 9 water quality parameters out of that. It's got a flow-through system and a pickup that works really well. Still use it today, and we used it after the oil field to map hydrocarbon concentrations. It's got a fluorometer in it as well for doing crude oil and refined fuels. Of course, we've got our SonTek M9, ADCP, or ADP as some people call it, just acoustic Doppler profiler. And so that gives us our continuous measurements of bathymetry, velocity profiles, and discharge if we need it. And then, of course, our RTK system. So getting into the case studies, I'll breeze through this one, at least the initial slides. I just wanted to give you an overview of some of the extended capabilities beyond just the HydroSurveyor and the River Surveyor that we have on the Jag Ski. A couple of years ago, a buddy of mine out of the Florida Institute of Technology, we did a water quality and ADCP survey in the Indian River Lagoon on the east coast of Florida. And the issue there for the past few summers, the lagoon had started crashing and with outbreaks of some fairly aggressive algae blooms that would start in the north of the estuary and work their way down. And we just happened to pick a week where we were both free, and there was a fairly large brown algae bloom at the time. There's a picture in the upper left of your screen. It's the Tall Over Canal, and there's a picture of a bridge going across a canal there. That's actually a man-made ditch that connects Indian River Lagoon with Mesquite Lagoon, if you look at the overview image there. And the water is brown in that picture. It looks like chocolate milk, and it's not supposed to look like that. That was actually an artifact of the algae bloom. And as we were running up, we started, see if you follow my mouse cursor down here, we started at Sebastian Inlet down here and then ran 167 kilometers over a period of about 7.5 hours up through Tall Over Canal here in Mesquite Lagoon. And as we would cross at about right here, there was actually visible fronts across the estuary where the water went from basically like a bluish green to chocolate milk. And so we knew we had found the algae bloom, and that's where it had gotten to at that point. So with our Seakeeper system, it continuously samples the water and records those measurements. And so over the 7.5 hours, we continuously collected over 2,000 water samples and did some physical sampling as well, and stopped and kind of hovered around some of St. Jerome River's water management district's long-term historical water quality monitoring sites, and doubled up on measurements there for them. So just a little anecdote of surveying and mapping water quality with the Jag Ski. It's a very robust system, and I should say that over the 7.5 hours I was not driving by myself. We actually had a follow-along car drive up, and we stopped for refueling and rest breaks and switching drivers periodically. But it's fairly intense. That just gives you an overview of collected data that's been triangulated to a surface of the estuary. And what I'm showing here is chlorophyll fluorescence and micrograms per liter. And so you see you start off very low chlorophyll concentration right here, which we're using as a proxy for the algae. At Sebastian Inlet, where it's well flushed by tides, and as we go up into the north part of the lagoon, we get some hits there. And you can see it almost this front that happened at this causeway where it went from very low chlorophyll to moderate to high chlorophyll, and it's exactly where we saw that front. But when we do the water quality mapping, we're essentially looking at temperature, salinity, pH, turbidity, dissolved oxygen, color dissolved organic matter, CDOM, and then fuels and oils. And not surprising, anytime we pass by a boat ramp or a marina, we get spikes in the refined fuels, as you might expect. Get into the velocity profiling a little bit. As part of that week-long field experiment, we also did some velocity profiling at 2 of the inlets. Where we're focused on Sebastian Inlet here, it's one of the main tidal drivers of that system. And even though it's a relatively small inlet, there's quite a bit of water that goes through it. Makes for a very challenging place to survey, actually. Unfortunately, we timed it well for the algae bloom, but this is a very misleading picture of my buddy here on the Jag Ski out in the middle of Sebastian Inlet, because you don't see any boats around. But that corresponded to the opening of mini lobster sports season, which means that for 2 to 3 solid days, it's nothing but boats. So it became a very challenging day to survey, which is why our vessel tracks over here at our 3 transects look a little bit erratic, because we had to deviate course quite a bit. But also, as you'll see in a following slide, the velocities going through there would reach over 2 meters per second. So it was a bit of a challenging place to do the survey. We stayed out there for about 9 hours, collected water quality samples with the Seakeeper system, all the while doing the ADCP profiling. So we ended up with over 100,000 measurements of velocity over the 9-hour period, all collected through actually the River Surveyor Live software package. And I think we had kind of pushed it to its max and had to close down and restart a few times, because that's a lot of data to collect. In the upper panel here, you're actually seeing some distilled or reduced flow measurement data. So in the early days of using the River Surveyor and River Surveyor Live, I'd actually kept pushing SonTek and my local or regional SonTek rep to try and come up with an interface for HYPACK or to develop their own proprietary software that would be HYPACK-like for collection of bathymetric data and also some different tools for doing the velocity profiling. And they've responded in a big way. And I will say that everything that you can do with the HydroSurveyor, most things you can do with the HydroSurveyor, you could have done with the River Surveyor Live. It just required a lot more work on the back end. But you can export all of the depth and velocity data from River Surveyor Live, either as MATLAB or ASCII text, and then do whatever you want with it. So this plot here shows just some average velocities at surface, depth average, and at the bottom, and then some CTD cast locations where we're using the CastAway CTD for sound speed corrections, and contoured, triangulated and contoured with the bathymetry map underneath it. So that's all just collected in River Surveyor Live, exported, and then processed after the fact. But I should say that River Surveyor Live actually offers some very helpful, I guess I would call data purification and correction options for correcting heading and for also cleaning up the data a bit before you export it. So that's a very helpful tool. So just basically looking at some reduced or distilled data from the velocity profiler. And then because we had the Seakeeper and we were continuously monitoring those 9 parameters at the surface, you can create these time stacks of flow across one of your transects and also the water quality parameters. In this case, you're looking at flow velocity and salinity as a function of time. And the vertical axis here is across the inlet. And reasonably, you could almost do the same thing with the CastAway CTD if you got a bunch of casts across your inlet and hung out the surface for a little while. That would be doable. So moving on to a more recent study. This is kind of a neat case study, an example, because it's shows how this system and the M9 can be used as a complete survey solution, but also as a complete solution for setting up a hydrodynamic model for as part of a different project. So this is actually a blend of research work and contract work. We were part of the team that's looking at potential restoration alternatives for a causeway that goes across the north part of Mobile Bay estuary, and it's called the Mobile Tensile River Delta. And actually, it's the second largest volume discharging system in North America. Quite a bit of flow comes through the two main rivers, Alabama and Tombigbee, and then distributes down into 5 rivers in the delta. Provides a tremendous amount of fresh water to the estuary, so much so, in fact, that sometimes fresh water signal can push all the way down 40 kilometers to the south, all the way to the Gulf of Mexico. So it's a big driver of hydrodynamics and also sediment transport and the transport of biota and pollutants in this part of the Gulf Coast. And in order to set up the hydrodynamic model, we had a base digital elevation model that would be used to set up the bathymetry for the circulation model. But then we actually needed to do some updating because some of our small tidal channels that we were trying to resolve in the model were too small to pick up by the relatively coarse DEM that we had at the time. So we went and did some updated mapping for bathymetry, but then we also did some velocity profiling across the rivers and some of the smaller tributaries as checks for the hydrodynamic model to validate and or calibrate it as necessary. So this project involves some tie gauge installation. So we surveyed in 3 tie gauges. You can actually see me there in a wetsuit installing a tie gauge below a pier there in our study area. And that was a particularly cold day down here, even though it was in March. And so then we left the tie gauge out there for 2 weeks and then hit the middle of the tie gauge deployment with our profiling. So in the next couple slides, I think there's a little bit of delay here, so I'm going to be cautious about clicking too many times. You'll see some of our profiling that we did across one of the rivers, and this was going across the Appalachian River, and this is just a direct screenshot actually out of the River Surveyor Live software. And this top panel shows bathymetry, so there's a deep channel here on the left side of the transect, and it comes up to a marked flat on the right. And then basically our vessel track and velocity profiles in the middle panel, and then the typical velocity type plot that you see of depth and range across the transect. So we repeated those transects a number of times throughout the day, kind of hopping from place to place. There's a different river that's further to the east. And used all this information, the bathymetric mapping, the discharge and velocity measurements, to set up and validate, calibrate the circulation model that we could then use to do run the alternative restoration simulations. So it's a neat project. It's kind of a lot of different aspects all lumped into one, and I really provided a complete solution, or turnkey solution I should say, to go out and do everything we needed to do. In this last case study here, as we wrap up my part of the webinar, really wanted to spend the majority of the time, or quite a bit of time, talking about this one, because this is actually, this project, we've seen a complete evolution of starting the project with River Surveyor and River Surveyor Live, and now moving to HydroSurveyor recently this year. We have as part of a research contract with the university, a long-term ongoing monitoring project at a place called Little Lagoon Pass. It's a very, very small tidal inlet. Used to be natural and ephemeral. It would change sometime. There would be 1, 2, or 3. Back in the 60s, it was stabilized with jetties because they got tired of rebuilding the bridge every time the inlet moved, go figure. But there's a very long, elongated east-west, but very narrow north-to-south coastal lagoon in Gulf Shores, Alabama. And it's primarily fed by fresh water, but it does need that tidal connection to flush it and to regulate or moderate water quality within the lagoon. And it's a nursery for very juvenile fish species and octopus, squid, all sorts of nice, yummy little creatures like to hang out in there. And the Alabama Department of Transportation is actually increasing the width of this path to promote improvements of water quality and increasing the length of their sheet pile jetties that extend perpendicular out to stabilize the inlet. And there's obviously some concern about trapping of sand, and so they required us to do the monitoring on a 3 times yearly or quarterly as needed basis after a storm event to go out and keep track of sand volumes in the system and develop a sediment budget for this pass, and just to give them some guidance on how to improve their seasonal bypassing that they do mechanically with the dredge. So this project involves some water quality monitoring of the lagoon, regular surveying of the ebb and the flood tidal shoals, surveying of the channel, and also surveying of beach profiles up to 2 miles east and west of the inlet. And again, you might be asking, well, you could just go out and do this in a boat and it would be much more comfortable. But as you'll see, I'm going to have Isaac click this little video, and hopefully it won't blast you with sounds. What you're actually seeing, there's probably some delay coming through, but it was just a video snapshot of a flood tide of the water coming in. And if you pay real close to the bottom, if you'll click that one more time for me so we can replay the music or the video. At the bottom, you'll see some sediment billows coming up. The velocity coming through here, and you can actually see some little hydraulic jumps forming in the channel. It gets well over 1 meter per second, sometimes 2 meters per second. It's a very challenging place to work. It's pretty narrow. That's only about 12 to 15 meters wide. And so trying to survey that with a boat would be nigh impossible, especially if you got broadside to the current. It'd be really hard to stay on track. The other possible solution here is to put your M9 on a hydro board, which is something that we're looking at doing, and setting up a tagline across the inlet to do maybe some 24-hour profiling across the inlet, because you can't convince anyone to sit on the jet ski for 24 hours and collect data. I don't know why, but the hydro board might be a good option here. So people always ask me why a jet ski, and I say, well, there are certain times when you really just need it, and that's certainly one of them. So we're doing surveying not only for monitoring, but also to set up and establish a hydrodynamic model of tides, waves, and sediment transport that can be used to kind of manage the site into the future. So this is when we started doing the project using River Surveyor and River Surveyor Live, we would take all the information, take all the profile data, and then clean it, distill it a little bit, and then interpolate, make our own maps out of it with some different software. So this is just ASCII exported data from the data collection sessions in River Surveyor Live, and then exported to a second software package for viewing and plotting. So if we zoom in, say on the channel survey, you can see my vessel tracks and the soundings there, just from the single beam unit, so looking at just the vertical beam transducer measurements there. And this was all very capable and doable. It required a little bit of work on the backside to make sure that your data were very clean and you were getting reliable data. So you would monitor, say, pitch and roll. You could actually use your elevation, if you filtered it a little bit, to compensate for heave. And that's actually gotten a lot better. But one of the challenging parts was always referencing your depth measurements to some consistent vertical datum. So we would always, and we still do, but we would always have to install and survey in a tide gauge and then take our depth measurements and the local tide and get those all resolved and interpolated in time space after the fact and get it back to a consistent vertical datum that could be used often in the future for analysis and surveying purposes. And that's gotten a lot easier now with HydroSurveyor. There's a lot less work to do on the backside, that's for sure. And so now let's talk about after HydroSurveyor. The planning software and navigation software in HydroSurveyor is excellent for conducting bathymetric or velocity profiling studies. There is somewhat navigation, you could say navigation support in River Surveyor Live. You can develop your own GIS shape files of your study area and plan lines and plan locations for doing CTD casting, and that's what we've done in the past. And bring those in and essentially just try and steer to that line in your display. And it works for the most part, but if you're trying to do something pretty sophisticated and something on a routine basis where you're going to want to go back and track the same lines over and over again, and if your lines are going to be spaced close apart, the navigation support that HydroSurveyor software provides is very good and very helpful. So now we've got excellent line planning software in HydroSurveyor. We've got real-time heads-up navigation support for steering your lines in HydroSurveyor. The CTD integration is also very good, as it is and has been in River Surveyor Live. So we use our CastAway CTD and then bring those data in after the fact when the survey is done to correct everything. There's very little extra work that you would really need to do to develop your bathymetric survey using HydroSurveyor. Your elevations now are absolute. If you're working with your RTK system, they're also very accurate. HydroSurveyor offers an interpolation feature that allows the user to set develop some options about the interpolation spacing and the area to interpolate. It's all very easy to use. It's basically point and click. You don't have to do any coding or programming or anything like that. And we found the interpolation to actually work really well, both for bathymetry and for the velocity. And the plotting features are also very capable, and for many things you may find that you actually don't need to export data and plot in a different software package, that you can just save directly from HydroSurveyor software or take a screenshot and crop out using MS Paint or something like that. Just to back up a second and provide a little bit of history, we did have the M9, and then we purchased the Smart Pulse code when that option became available. Then we bought the CastAway CTD. Then we upgraded to HydroSurveyor, and then recently upgraded to the new power and communication modules, which provide an absolute or fixed RTK solution for your surveys. And so now there's really no need anymore to do this this monkey business with correcting to a local tide gauge after the fact and interpolating and still wondering if you actually got those values correct. If you've got the upgraded PCMs like we do now, then you've got a fixed and absolute vertical reference now, and all you have to do after the survey is convert from ellipsoidal elevation to orthometric, which most software packages, most GIS programs can do, and you can always use NOAA's free VDatum tool, which is very good for transforming horizontal coordinates and vertical datums. So there's really takes a lot of the guesswork out of it, and also for on the RTK side provides a little bit better, can provide better heave compensation if you want to compensate for that after the fact, which sometimes we have to do for the beach profile surveys if it's a particularly lumpy day on the water. The HydroSurveyor package also gives some other real-time heads-up plots and of course post-process plots as well, or post-survey plots. Some different parameters. Actually drills down a lot more into all of the capabilities, extended capabilities of the instrument. So here I'm showing a color map time series that I've kind of chopped down and cropped so you can see detail of the vertical beam signal to noise ratio. So high at the surface and then the high again at the bottom, picking up the reflections at the bottom. And there are all sorts of color map time series that you can make from velocity and depth and signal to noise ratio and all sorts of different things. So a lot of good capabilities within the software itself. And with the few minutes remaining here, I wanted to step you through say what I would have to do and what I have done to perform a survey of the flood shoal here at Little Lagoon, and just reduced it down to 10 steps with corresponding images on the right. So the first thing I did was use the native mapping images that HydroSurveyor has in it, HydroSurveyor software, to cache a local image of my study area. That way, when I don't have internet connectivity on the water, I can still have my background image if I want it. And so I use that for both line planning the survey and also conducting the survey if I want to see it. Second thing would be to import my old line plan shapefile that I was using for River Surveyor Live, or create a new one if you want, or if you've got an existing one from somebody else, you can import that. It just has to be in a shapefile. Then I just created a new, updated, and improved line survey plan on top of that within HydroSurveyor software. And I changed it up a little bit because we had found that our line plans weren't working out so well, so we improved them a bit. Then you can go out and do a lot of field recon and revise and go through your setup if you need it. And let's see, kind of lagging behind here. Let's wait to advance the next slide. There we go. Now we're back on track. And then go out and perform your work. And so if Isaac will, with his magic mouse, click on the video, all I did was essentially use HydroSurveyor software's native survey playback capabilities to record and clip out a small snippet of a survey. And so you see actually some of the parameters changing in the little red boat going along the track line, and you can see the signal to noise ratio over the depth at the bottom and the compass parameters at the right. So it's just a little playback of actually conducting a survey. And then see if I can get control and advance to the next slide again. So now just showing the line plan survey with my vessel tracks over to the top. You can see it took me a while to get used to the conditions at the site, and then my lines got progressively better instead of getting worse, which was good. But there's a lot of boat traffic that day, so you can see a lot of deviations from the tracks, and that happens. Review bathymetry soundings. So you can see soundings around the tracks now. And then kind of clean it up a little bit and look to the interpolated bathymetry of the flood shoal. You can then also look at velocity measurements. Trying to advance forward. Can you click it forward for me, Isaac?
Sure thing.
So there are velocity vectors, kind of noisy because they were all collected at different times throughout the day. And then click on to the next slide, and there's basically interpolated velocity field, which again looks a little noisy because they were collected at different times. And then last slide, so click ahead. Let's go over a few tips and tricks. Bullets will come up one by one as you click. So can't really emphasize enough the importance of doing some reconnaissance at your site. But before you go out for an initial survey and before you go back for a follow-up survey or routine surveys, it's really important to go out and get a grasp of what the site's like and what the conditions are like. That's going to help you a lot with your line planning. Moving on to the next bullet, make sure you provide a good, stable RTK setup that's got line of sight, preferred line of sight to where you're going to be working. and then be prepared to have multiple setups if you're working across a large area like we are. So we can go out and pound some stakes into the ground early on and flag them and record the elevations. Next bullet. And be prepared to convert some elevations in the field. So typically, if you're working with RTK survey equipment, you'll be getting an orthometric elevation, say in feet or meters relative to a survey datum, and you'll need to be prepared to convert those to an orthometric or ellipsoidal elevation to put it into the HydroSurveyor software. So just be aware of that. So we just take a logbook out and record those values and convert them and then communicate back to me via VHF radio on the jet ski. Next bullet. Know your mapping area and expected depths so you can plan accordingly and also figure out if something's going wrong on the water if you see some abnormal readings coming in. For instance, I forgot to put the ADCP in the water after having already finished 2 lines. Silly me, so I realized that something had gone horribly awry. Next bullet. Believe it or not, that kind of stuff happens. And make a smart survey plan. That'll greatly improve your success. Next bullet. Make your navigation corridors generous. So I started off thinking, well, I can make them pretty narrow. I'm a pretty competent navigator, and I realized that it's not only me, it's the conditions at the site and the people that are in your way. And so it's nice to make the navigation corridors and the HydroSurveyor software as big as possible so you can keep your track reference. And then go ahead and just throw up the last 1 or 2 bullets. Be patient when you're using the new PCMs. They will sync, especially the first time. There's a little bit of a lag maybe, but they pick them up. They pick each other up and see each other eventually. And then make sure you practice with this stuff before you head to the field. Our field site is about an hour and a half away. And I wish I could practice a little bit more, but there's a little bit of a learning curve in terms of interfacing with the software, especially with my setup. Be a little bit easier with a standard laptop, but with my touchscreen interface, it was a little goofy on my part, and I had to get used to everything. But that kind of wraps it up from my part, and I know we wanted to leave as much time at the end for questions as possible. So with that, I will kind of mute myself for the time being.
All right. Thank you very much, Brett. We have one question for you off the bat from Brazil. Or actually, I'll wrap it up and then we'll get to questions. Sorry.
All right.
Ahead of myself. Okay, so just to wrap it up and come full circle, Bret has done an excellent job of demonstrating what it's like kind of to use HydroSurveyor in the field and the evolution from River Surveyor Live all the way to HydroSurveyor. But just to hit on it once again, HydroSurveyor is it's a central compact recording and processing platform. So the M9 is not very big, and then the PCMs are compact as well and waterproof, so it enables something like the Jag Ski. So it works with the Jag Ski and other small platforms. It's a 5-point depth sounding device, so it's an ADCP, but it also is a depth sounder and gives 5 different points. It profiles the water velocity, and it's a solution that has integrated GPS, but can also switch to bottom tracking. So if you lose GPS, you're not out of luck with your boat track. It can switch to bottom track and then back to GPS if you get GPS again. And then full compensation for speed of sound is available with the CTD. You can also correct with other sound speed probes, but the CastAway CTD is fully integrated with software. And with the SonTek GPS options, we have fully integrated positioning. And that pretty much does it. I'm going to wrap it all up by showing some other kind of cool mobile mounting examples in the spirit of the Jag Ski. We have customers and SonTek employees who have done surveys using kayak with the PCM and the HydroSurveyor. It's possible to use very small mobile platforms. Down here on the bottom left is our HydroBoard 2, so this is the next generation of our HydroBoard. If you're going from one vessel to another and you never know what you're going to be working off of, this is a good solution because it can be towed off the side of a boat, and or it can be towed back and forth across an inlet without getting in the water as well. And this top right solution shows our mobile phone solution for River Surveyor Live. That's not an option for HydroSurveyor, but it also shows a remote boat which can be used for HydroSurveyor. So without the user having to get in the water, you can perform a survey from a riverbank or the bank of a reservoir. And the bottom right is just another example of a different remote boat. And so with that, thank you all very much for attending, and Bret and I will answer questions for the next 10 minutes or so. So Bret, there's a question for you from Brazil. What are the rougher conditions you've used the Jag Ski system for? Is it stable enough for offshore use up to 20 meters?
So I'm guessing that's 20-meter depth and not 20 meters offshore.
Yes.
Well, just from so I've grown up and used boats my entire life. I grew up on the water. I'm actually a licensed captain, and so I'm very familiar and comfortable around the water. What I'm not so comfortable with is the reliability of my jet ski to always be on and, you know, propelling me somewhere. And so there are some real limits about how far offshore I will go. And essentially it's line of sight. If somebody can't see me from the beach, I'm not going any further. And so at that point, we have actually used it further offshore, and we've put it on a research vessel and gone offshore and done work around the vessel. But I never stray out of line of sight, certainly never out of line of communication. You know, if I'm working in the estuary and I feel a little bit more protected, then it's not really an issue. And conditions aren't an issue for the jet ski, but they are for data collection. So as it turns out, if you're going to go out and do ADCP profiling, either for a bathymetric survey or for velocity or discharge profiling, you really need calm conditions to get quality data, so the conditions don't become so much of a factor for the personal watercraft. So if it's a calm day, conceivably you can go as far offshore as you want. We generally only go about 1.5 miles to 2 miles offshore, which gets us to a depth of about 10 to 12 meters. So that's generally about as far as out as we'll go. But you know, one of the reasons why we started using personal watercrafts to survey is to get across the surf zone, a place where you would traditionally not take a larger vessel. It's from a maneuverability and standpoint that we can get over the longshore bar and over through the braking zone and then turn around and get back out in a hurry if we need to. You need to roll over and capsize. It's not a big deal. Everything, like Isaac said, is IP67, or on my system, some of the boxes are IP68 rated. One thing I will say is that I pretty much have every single piece of SonTek equipment submerged at one point in time, and it's all worked flawlessly. Never had a problem. I have learned that other manufacturers and other equipment that I purchased has said waterproof, but didn't say IP67 or IP68, can't really be trusted. If it just says waterproof, it really is more like water resistant on a jet ski.
Thank you, Bret. And that also brings up some some of the other questions we've gotten is, one question is, does the M9 require a motion reference unit? And so that comes into play with rougher water farther offshore. The M9, or the HydroSurveyor does have a pitch and roll sensor, so it is compensated for the depth locations are compensated for pitch and roll, but that's to a point, because to a certain extent, if you're getting greater than 15, 20 degrees pitch and roll, the M9 is no longer aimed down at the bottom; it's more horizontal. So that could be a limitation if it's very rough. But the system should be able, depending on water conditions, should be able to get depths and velocity up to 20 meters, up to actually 40 with all 4 beams, and then up to 80 meters with the vertical beam. Okay, so next question. Can you use HydroSurveyor in all situations where you need to use the River Surveyor system? The answer is yes. You have to switch between the 2 softwares. You need to have a license for HydroSurveyor and River Surveyor. HydroSurveyor does not compute discharge. It's not a product of that's not what it's designed to do. So, but it is possible, and we do have users who have River Surveyor Live, like Dr. Webb, that you go and take a transect, computed discharge, and then switch software packages if you have the license and the firmware upgrade for HydroSurveyor, and then start a hydrographic survey afterwards. And Bret, do you have any questions on your end?
Yeah, I'm seeing some questions here. One was about, see a question, the viewing platform you're using, was it mounted on the front of the Jag Ski? Yes, we use an 8-inch touchscreen LCD display. It's mounted on the front of the Jag Ski right above the handlebars. And so I can see it at all times. It's got a very nice brightness to it. And you can either use your finger, or, as I have learned, my fingers are too stubby to click little boxes on the screen. So I actually use my stylus that comes with the CastAway CTD to interface with the software. And there are a bunch of waterproof displays out there. Mine is made by Vortec. And we're probably going to go up to a 10-inch display now with the HydroSurveyor software to have a little bit more desktop space where we can see more sensors and windows while we're doing the surveying. Got another question about how shallow can you measure with the Jag Ski system? Well, actually, we mount our ADCP pretty low in the water to make sure that it's always below the hull. You know, we're not surveying at fast speed. We're always trying to survey at, you know, about a meter per second or 2 meters per second vessel speed or less, just to get quality measurements. And so as a result, bubbles really aren't a problem off the hull. But I've found that I'd rather sacrifice the top 20 centimeters of the water column for what I do, and get really good, strong quality data that's not bouncing off the hull. So really, our depth is limited by how deep we mount the ADCP, but I've surveyed in about 30 centimeters of water. Half a meter of water is actually a little bit more realistic of a goal. Of course, if you're willing to put the ADCP right at the surface, where only the heads need to be wet, as long as they're continuously wet, you could get a much shallower water.
So I have another one here. How long will it take new PCMs to synchronize with the system? So there's two different things I'll talk about there. When you first get